watching InfiniteSpaceLink episode 4. Today we're going to be going through a couple things. For starters, I'm going to be discussing 4 different types of potential or already existing rocket propulsion methods. I'm going to be making chocolate milk in a very efficient way. And then I'm going to be discussing something that looks really good on college applications. So be sure to like and subscribe if you haven't already, and hit the bell button so you can be notified immediately whenever I upload a video. So let's get started. Okay, so for starters, to get a rocket moving, you need a force produced by the rocket called thrust. Thrust is created by various methods, which I'll be discussing. Essentially, it involves expelling something in the opposite direction you want to go. What gets expelled and how it's done makes the difference between methods. The thrust is a action force. According to Newton's third law, every action has an equal and opposite reaction. The rocket uses the energy it obtains to produce thrust in one direction, causing it to move in the opposite direction. Now I'll discuss the different methods of producing thrust. So one method would be chemical propulsion. Chemical propulsion is the main form of rocket propulsion. So in chemical propulsion, a fuel and an oxidizer, which are propellants, are mixed and converted to gases expelled through the rocket's nozzle. There are 2 types of chemical propulsion methods. One would be the usage of solid rocket motors, and the other would be the use of liquid rocket engines. Liquid rocket engines typically use liquid hydrogen as fuel and liquid oxygen as an oxidizer. Solid rocket motors typically use aluminum as the fuel and ammonium perchlorate as the oxidizer. For liquid rocket engines, the propellants are stored in separate tanks and then combined in a high-pressure combustion chamber, causing the conversion to the gaseous state with 2 main methods of contribution. One would be the ignition, and the other would be the fact that the high pressure breaks the intermolecular forces of the combined propellants. For solid rocket motors, the propellants are pre-combined and converted to gases by ignition. As previously stated, the propellants shoot out of the rocket nozzle in the form of exhaust, which is hot gas, creating a force acted upon in a certain direction. The most important difference is that in liquid-powered rockets, you usually pause the thrust ejection, while in solid-powered rockets, you cannot do so the propellants just burn from the core of themselves continuously. Solar propulsion, also known as the usage of solar sails, typically involves the usage of photons ejected by the sun to hit thin reflective material, and by reflective material, I mean material that reflects electromagnetic waves such as light rather than absorbing it. So reflective material to hit thin reflective material to move a rocket. Typically, this would only be used when moving and adjusting a rocket in space, not to get it out of the Earth. This makes sense in general, like the idea of the photons moving it, because say you're holding up a paper in the air and someone throws a football at it, the paper will move and would probably move further if it was somehow floating and you weren't restricting it and holding it. The issue is that photons are small, and while solar sails are thin, this still makes it hard to get spacecraft to travel long distances in a short period of time. However, in the long run, solar sails could be a good solution because the sun produces renewable energy. NASA recently started using solar sails in its mission called Advanced Composite Solar Sail System, also known as ACS-3. It is to demonstrate what solar sails can do and to test them out. So another method would be nuclear thermal propulsion. The main difference between nuclear thermal propulsion and chemical propulsion is the heat source. Both expel exhaust. However, in chemical propulsion, the propellants are combined and then ignited. In nuclear thermal propulsion, the propellants are combined and then converted to exhaust by being heated from heat generated by fission. Fission is the process of radioactive elements, which are unstable elements, decaying to become more stable. This produces huge amounts of energy in the form of heat from tiny amounts of mass. This is also where Einstein's equation E equals mc squared comes from, where E is the energy, m is the mass, and c is the speed of light. The heat and ignition both increase acceleration of what they both convert into exhaust, but the heat does so much more efficiently, and as previously stated, you can tell by the equation. This makes nuclear propulsion better for long-term missions such as going to Mars. However, for short-term missions like getting a satellite into low Earth orbit, the cost and risks due to the lack in testing make its worthiness questionable, so it has not been used in rockets yet. However, there has been testing for it, or nuclear propulsion, and it is likely to be a big thing in the future of space exploration. So we also have antimatter propulsion. Antimatter is matter with opposing properties in terms of charge and / or quantum numbers to another type of matter with the same mass per particle, or like per molecule, I don't know. An example would be subatomic particles. Like in terms of subatomic particles, a positron is considered antimatter because it has opposing properties to an electron. It has the same mass but a positive charge rather than a negative charge. When antimatter comes in contact with its opposing matter, it becomes a huge amount of energy, which could be used for rocket propulsion. However, antimatter propulsion is a theoretical concept. Its science is understood, but it hasn't been tested yet, mainly due to the rarity of antimatter and its cost. Something that looks really good on college applications is doing a high school summer program at top colleges. These tend to give you high-level coursework and high-level hands-on experience. They also give you some experience with the college. An example I found would be Columbia's SHAPE program, which has college-level coursework in several engineering fields, along with the hands-on projects. Some practical things that look good on applications for these types of programs would include applying before the priority deadlines, good grades, and relevant extracurriculars and projects. For anyone in high school right now, I wish you guys good luck on your journey through. I hope you enjoyed this video. Be sure to like and subscribe if you haven't already. Be sure to check out some of the videos on my channel, and I will see you next week.